Alright, let's break down how to get your Typesense instance up and running, and how to snag that all-important API key. So, the very first thing is getting your Typesense instance ready. Think of it as setting up your own little Typesense server. Securing an API key is vital for authentication and access control. This is what allows your LangChain application to talk to your Typesense instance. Firstly, it's like getting a password, so make sure this key is obtained from your Typesense setup. It's crucial to store the API key securely, and environment variables are the recommended way to do this. Think of it as keeping your password in a super safe place. Configuring the connection parameters involves setting up the host address, port number, and protocol to ensure seamless communication with the Typesense instance. Now, let's define the schema in Typesense. It's like setting up the structure. For your data, telling Typesense what kind of information it will be storing. The name of the collection, for example, my_documents, is how you'll refer to this set of data in Typesense. Field definitions specify the data types for the information you will store, such as text as string, embeddings as float array, and other metadata as a string. So, here we're dealing with a field type designated for textual data. This is where you'll store the actual text content of your documents. This field will hold vector embeddings, represented as an array of floating point numbers. It's specifically for storing numerical representations of text or images. This is a string field designed to store additional information that's related to each document, such as the source URL. Now, let's dive into indexing. It's like creating an index in a book, making it faster to find what you're looking for. Enabling indexing on the vector field allows to perform efficient similarity searches by optimizing the retrieval of vector embeddings. HNSW, or Hierarchical Navigable Small World, is a commonly used indexing algorithm for vector search, known for its performance. Alright, let's create a Typesense Vectorstore and store document embeddings using the Typesense client object. The Typesense client object serves as the primary interface for interacting with the Typesense instance, managing connections and executing actions within Typesense. Configuring connection details involves setting up the host, port, protocol, and API key to enable seamless communication with the Typesense instance. So, here you're creating the LangChain Vectorstore and connecting it with the Typesense client to allow you to interface with it, using that client. Here the Typesense Vectorstore is initialized with the client, collection name, and embedding function to enable efficient vector storage and similarity search functionalities. Once initialized, document embedding and storage can be seamlessly performed, adding vector embeddings to the Typesense Vectorstore. Now, convert your text documents into vector embeddings using an embedding model, then add them to the Typesense Vectorstore.